Assalamu alaikum, dear students. Let us understand the concept of symmetric matrix. A square matrix A is said to be symmetric if A transpose is equal to A. Example: A is a square matrix of order 3 by 3. Then A transpose is obtained by changing the rows into columns of matrix A. So A transpose is equal to matrix having elements 1, 2, 3, 2, minus 1, 4, 3, 4 and 0. So A transpose is equal to matrix A. Thus A is symmetric matrix. Now let us understand the concept of skew-symmetric matrix. A square matrix A is said to be skew-symmetric if A transpose is equal to negative of A. Example: A is a square matrix of order 3 by 3. Then A transpose is obtained by changing the rows into columns of matrix A. So A transpose is equal to matrix having elements 0, minus 2, minus 3, 2, 0, minus 1, 3, 1 and 0. Now taking common the negative signs of matrix A transpose, that is equal to matrix having elements 0, 2, 3, minus 2, 0, 1, minus 3, minus 1 and 0. So A transpose is equal to negative of matrix A. Thus A is a skew-symmetric matrix. Exercise 1.3. Here question 8 is: if A is equal to matrix having elements 1, 2, 0 and 1, B is equal to matrix having elements 1, 1, 2 and 0, then verify that in first A plus B whole transpose is equal to A transpose plus B transpose. In second, verify that A minus B whole transpose is equal to A transpose minus B transpose. In third, verify that A plus A transpose is symmetric. In fourth, A minus A transpose is skew-symmetric. Solution: in first, A plus B whole transpose is equal to A transpose plus B transpose. So left hand side is equal to A plus B whole transpose. In first, we find the sum of matrix A and B. So we add their corresponding elements of matrix A and B. So in matrix A, here first element is 1. In matrix B, here first element is 1. So 1 plus 1 is equal to 2. 2 plus 1 is equal to 3, 0 plus 2 is equal to 2 and 1 plus 0 is equal to 1. This matrix is the sum of matrix A and B. Now we take the transpose of this matrix. So the transpose of that matrix is equal to matrix having elements 2, 2, 3 and 1. This is equation number 1. So right hand side is equal to A transpose plus B transpose. So in first, find the transpose of matrix A and matrix B. So transpose of matrix A is a matrix having elements 1, 0, 2 and 1 plus the transpose of matrix B, that is equal to matrix having elements 1, 2, 1 and 0. Now find the sum of these two matrices. We just add their corresponding elements. So 1 plus 1 is equal to 2, 0 plus 2 is equal to 2, 2 plus 1 is equal to 3 and 1 plus 0 is equal to 1. From equation 1 and 2, both the matrices are same. So left hand side is equal to right hand side. From equation 1 and 2, A plus B whole transpose is equal to A transpose plus B transpose. In second, verify that A minus B whole transpose is equal to A transpose minus B transpose. left hand side is equal to A minus B whole transpose. In first, we find the difference of matrix A and B. We subtract matrix B by matrix A. So we just subtract the corresponding elements of both matrices each other. So 1 minus 1 is equal to 0, 2 minus 1 is equal to 1, 0, minus 2 is equal to minus 2, 1, minus 0 is equal to 1. Now take the transpose of that matrix, that is equal to 0, minus 1, minus 2, 1 and 1. This is equation number 1. Right hand side is equal to A transpose minus B transpose. In first, we find the transpose of matrix A and matrix B. So the transpose of matrix A, that is equal to matrix having elements 1, 0, 2 and 1 minus the matrix having elements 1, 2, 1 and 0. Now find the difference of these two matrices. We just subtract their corresponding elements each other. So 1 minus 1 is equal to 2, 0 minus 2 is equal to minus 2, 2 minus 1, that is 1, and 1 minus 0 is equal to 1. This is equation number 2. So from equation number 1 and 2, left hand side is equal to right hand side. So A minus B whole transpose is equal to A transpose minus B transpose. In third, A plus A transpose is symmetric. For symmetric, A plus A transpose whole transpose is equal to A plus A transpose. So in first, we find the sum of matrix A with matrix A transpose. So the transpose of matrix A, that is equal to matrix having elements 1, 0, 2 and 1. Now find the sum of these two matrices each other. So add the corresponding elements of these two matrices. So 1 plus 1 is equal to 2, 2 plus 0 is equal to 2, and 0 plus 2 is equal to 2, and 1 plus 1 is equal to 2. This is equation number 1. Now find the transpose of A plus A transpose. So A plus A transpose we find in equation number 1. This matrix is equal to elements 2, 2, 2 and 2. Now take the transpose of that matrix, that is equal to matrix having elements 2, 2, 2 and 2. So from equation number 1 and equation number 2, A plus A transpose is symmetric. In fourth, A minus A transpose is skew-symmetric. To prove A minus A transpose whole transpose is equal to negative of A minus A transpose. So in first, we find the difference of A matrix and matrix A transpose. So first we find the transpose of matrix A, that is equal to matrix having elements 1, 0, 2 and 1. Now find the difference of these two matrices. We just subtract the corresponding elements of both matrices. So 1 minus 1, that is equal to 0, 2 minus 0 is equal to 2, 0 minus 2, that is minus 2, 1 minus 1 is equal to 0. This is equation number 1. Now find A minus A transpose whole transpose. Their sign is minus sign. So that is equal to matrix having elements 0, 2, minus 2 and 0. Now take the transpose of that matrix, that is equal to 0 minus 2, 2 and 0. Now taking common the negative signs of that matrix, that is equal to matrix having elements 0, 2, minus 2 and 0. From equation number 1 and equation number 2, A minus A transpose is skew-symmetric. Thank you, student.